Basic Mechanical Drives, Part 4, based on a SlideShare presentation by James Shearer, adapted and presented by me, Jean Legui. Here's the legal stuff. So we're looking at different types of mechanical drives. This time we're looking at chain drives. Metal chain drives are normally used for applications below 3000 RPM, where accuracy and reliability must be greater than that provided by rubber belts. Because metal chain does not stretch very much or slip as a belt does, chain drives maintain constant speed ratios under widely varying load conditions and need adjustment less frequently. Reliability of a chain drive is better than that of a belt, with chain servicing life typically rated at 10,000 hours. That's about 3 to 4 times longer than a belt. Chain drives generally are more compact than similarly rated belt drives. For example, a 7.5 kilowatt chain drive is about half as big as a comparable belt. Chains can be replaced more easily than belts because sheave adjustment is not changed for the replacement. Chains can be removed by simply pulling out a master pin in the link and threading the new chain through the drives. But because chain drives do not slip, they cannot provide the overload and jam protection of belt drives. Also, the heavy weight of metal chain compared with light rubber belts produce penalties in efficiency cost and response time. Efficiency for chain drives, about 85 to 90%, is slightly less than that of conventional belt drives. And chain drive costs about 20 to 50% more than the belt drives, with prices ranging from about $300 to $10,000. Chain drives use two types of links: self-forming teeth and extended pin. Self-forming teeth have slats that extend on either side of the link and conform to the rib side of the sheave faces for a positive engagement. This type usually transmits up to 20 kilowatts and operate at a speed of about 900 RPM. The extended pin type, with pins projecting on either one or both sides of the link, engage the sheave face. These transmit from 5 kilowatts to 75 kilowatts at input speeds up to 2,900 RPM. In the range 5 to 20 kilowatt rating for the two link types overlap. Chain drives are used to transmit power between a drive unit and a driven unit. They consist of one or multiple strand chains, depending on the loads that the unit must transmit. The chains need to be matched with the sprocket type, and they must be tight enough to prevent slippage. Chain is sized by the pitch or the center-to-center distance between the pins. This is done in 100 mm increments, and the pitch number is found on the sidebars. This is often in inches also, and is done in that case in 4-inch increments. Here's an example of a chain drive used for timing on a motor. Unlike belt drives, chain drives do not slip, therefore there's no power loss due to slippage. Chains are more compact than belt drives for a given capacity. Chain drives are narrower than belt drives, and the sprockets are smaller than the sheaves. Chain drives are more practical at slow speed, yet will operate efficiently at high temperatures. Generally, chains are easier to install than belts. They're not subject to deterioration by oil, grease, or sunlight, and generally withstand chemical and abrasive conditions. Chains can operate in wet conditions. Chain stretch under normal operating conditions is slow, and chains require less take-up adjustments than do belts. chains are very effective in driving several shafts from one common drive shaft. They're generally simpler and less costly than gear drives and can be used with varying shaft center distances, and are suitable for use on reversing drives. However, they cannot be used where the drive must slip. They don't accept any form of misalignment. They're noisy. They can cause vibration. They require frequent lubrication. And when compared to gear drives, chain drive load capacity is generally smaller and the service life is shorter. Chains are used to transmit power from one rotating shaft to another. On a typical chain drive, the drive and sprockets rotate in the same direction and maintain a positive speed ratio for the machines. In most applications, a chain that has even number of pitches will be used on a sprocket with an odd number of teeth, and a chain with an odd number of pitches will be used on a sprocket with an even number of teeth. This limits developing a wear pattern on the sprockets by having different lengths of chain contacting the sprocket teeth on different revolutions, similar to that of using not whole number gearing ratios to limit the wear on gear teeth. The size of the sprocket in a chain drive system determines the speed relationship between the drive and driven sprockets. For example, if the drive sprocket has the same size sprocket as the driven, then the speed will be equal. If we change the size of driven sprockets, then the speed of the shaft will also change. If we know what the speed of the electric motor is and the size of the sprockets, we can calculate the speed of the driven shaft by using the formula. And the answer is 900. The chain length can be found using the following formula. A 40 chain has a pitch of 12.7 millimeters. I'll give you a few moments. And the answer is approximately 1,894 millimeters. In order to calculate the speed of the chain in meters per minute, we need some information. We need the number of teeth on the sprocket, the shaft RPM of the sprocket, and the pitch of the chain in millimeters. With this information, I calculate, and I'll give you a moment, and the answer I make it is approximately 137 meters per minute. Here's some example of some chain drives. Sprockets and roller chains do need some maintenance. Roller chains are made up of roller links that are joined with pin links. The links are made up of 2 sidebars, 2 rollers, and 2 bushings. The roller reduces the friction between the chain and the sprocket, thereby increasing the life of the unit. Roller chain is sized by the pitch or the center-to-center distance between the pins. This is done in an 1/8 inch increments, 3 millimeter increments, and the pitch number is found on the side bars of the chain. Large pitch conveyor chain have the same basic structure as a double pitch conveyor chain, but there are some differences. Large pitch conveyor has a headed pin, sometimes a flanged F-roller, and usually does not use a riveted pin. Large pitch conveyor chain is also called engineering class chain. As you can see, the chain consists of a set of side plates, pins or rivets, sleeves and rollers. In the diagram we show the major friction and wear areas. You can easily see that the wear on the pins and the inside of the sleeves will result in chain slack. Wear in the roller and outside of the sleeve will allow the link to settle lower down on the sprocket tooth. HL is half link. Lubrication is used to reduce friction and reduce wear. Hand oiling means applying oil by hand using a hand oiler or brush, normally at least once every day, while slowly turning the chain. Apply oil evenly 3 to 4 times onto the entire length of the chain. Be careful not to allow hands or clothing to be caught between the chain and the sprocket. When the mechanism is run for the first time after oiling, avoid excessive oil splashing. Drop lubrication is a manner such as where oil drops, are allowed to fall onto the chain automatically. Approximately 5 to 20 drops of oil are applied per minute. Oil bath lubrication. The chain is dipped in a bath of oil 10 millimeters below the oil level. It's recommended that a simple casing be installed over the chain to prevent oil from splashing. Use a leak-free oil container. Wash it carefully to remove dust, dirt, and other foreign particles. Maintain the correct oil level and do not overfill. Rotating plate lubrication. The chain is oiled by plate approximately 20 millimeters below the oil level. The peripheral speed of the plate should be 200 meters per minute or faster. Forced circulation. Adjust the oil quantity as appropriate to prevent overheating. Use a leak-free oil container. Before installing the oil container, wash it carefully to remove dust, dirt, and other particles. Here's an example of a large roller chain used on a conveyor. Sprockets are fabricated from a variety of material. This would depend on the application of the drive. Large fabricated steel sprockets are manufactured with holes to reduce the weight of the sprocket on the equipment. Because roller chain drives sometimes have restricted spaces for their installation or mounting, the hubs are made in several different styles. Type A sprockets are flat and have no hub at all. They're usually mounted on flanges or hubs of the device that they are driving. Type B sprockets, hubs, are flush on one side and extend slightly on the other. The hub is extended to one side to allow the sprocket to be fitted close to the machinery that they are mounted on. Type C sprockets are extended on both sides of the plate surface. They're usually used on the driven sprocket where the pitch diameter is larger and where there is more weight to support on the shaft. Type D sprockets use a Type A or B sprocket mounting on a solid or split hub. The sprocket is split and bolted to the hub. This is done for ease of removal and not practicality. It allows the speed ratio to be changed easily by simply unbolting the sprocket and changing it without having to remove bearings or other equipment. The slack on the chain should be located on the bottom strand. It is desirable that a chain wrap of 120 degrees is achieved, but under no circumstances should the chain wrap be less than 90 degrees. In vertical chain drive arrangements, the chain will tend to hang off the lower sprocket. This is especially true if the driver sprocket is at the lower position. Therefore, it is desirable that the shaft centers be arranged such that they are at least 20 degrees off true vertical. When the proper procedures are followed for installing chains, they will yield years of trouble-free service. Shafts must be parallel or the life of the chain will be severely shortened. The first step is to level the shafts. The next step is to make sure that the shafts are parallel, measuring at different points on the shaft and adjusting the shafts until they are an equal distance apart. Make sure that the shafts are pulled in as close as possible before performing the procedure. The jacking bolts can be used to move the shafts apart evenly after the chain is installed. Before installing a set of used sprockets, verify the size and condition of the sprockets. Install the sprockets on the shafts following the manufacturer's recommendations. Locate and install the first sprocket. Then use a straight edge or a string to line the other up with the one previously installed. Install the chain on the sprocket, then begin increasing the distance between the sprockets by turning the jacking bolts. Do this until the chain is snug but not tight. To set the proper chain sag, deflect the chain 6 mm per 300 mm of span between the shafts, using a string or straight edge, and place it across the top of the chain. Then push down on the chain just enough to remove the slack. Use a tape measure to measure the amount of sag. Many times when you need to change a chain, you can't tell the original size. One way of telling the size is to lay the new chain down on the old chain, but remember that the old chain may have stretched. Or maybe you're installing a new drive and you want to have the chain made up before you install it. So how do you know the size? One method is to take a tape measure and wrap it around the sprockets to get the chain length. However, this is not a very accurate way to determine the length. Instead, there's another method. First move the sprockets together until they are as close as the adjustment will allow. Then move the motor or drive out 1/4 of its travel. Now we take some measurements. We take the following measurements. The number of teeth on the drive sprocket, the number of teeth on the driven sprocket, the center to center distance between the shaft, and the chain pitch in millimeters. We then determine the chain length using the equation that you were given earlier. Chain length cleanliness and proper lubrication are vital to your chain's long life. Foreign material left on the chain can have an abrasive effect when mixed with the lubricants and cause excessive wear. Check for evidence of wear. If the inside surfaces of a roller chain link's sidebars appear to be worn, then the drive is probably misaligned. Inspect chains for flexibility. Stiff chain joints can be the result of dirt or grit in the rollers. Inspect the amount of chain stretch or elongation. A single pitch roller chain should be replaced if the amount of stretch is equal to or greater than 3% of its original length. Check for any signs of physical damage to the chain, such as broken or cracked parts, loose pins and bushings, or indications of corrosion. Check the chain for elongation by examining the conveyor operation of the sprockets. A worn or elongated chain will ride higher on the sprocket teeth. The side of a sprocket teeth should be inspected for signs of wear, indicating possible alignment problems. Check the teeth for signs of wear, indicated by a hooked shape. This is normal wear, which may have been accelerated by a loose-fitting chain. In some cases, it's possible to turn the sprocket around and extend its life. Inspect for signs of physical damage to the sprocket, such as broken or chipped teeth or excessive corrosion. Check the sprocket runout on the shaft and inspect the keys and keyways for wear or damage. The use of a worn drive chain causes the sprocket teeth to wear. The wear is evident by scratches, groove patterns, polished surfaces, galling, or visible changes in tooth formation. Replace sprockets when worn teeth show physical changes, such as visible tooth deformation, wear patterns. Typically, the chains and sprockets are replaced as a unit. Inspect a chain for wear by inspecting the leaks for worn bushings. Lubricate chain with a lightweight oil recommended by chain manufacturer. Check chain sag. Measure the chain sag using a straight edge or string and check it meets specifications. Inspect sprockets for worn teeth or abnormal wear on the sides of the sprockets. And that is the end of part 4 and the end of this series of videos on drives. Thank you.